What up? Alright, so before I make a formal video on this, I just want to kind of talk through it. And the cool thing about using Google AI is, hey, it can kind of check to see if what you're saying even makes sense. And so let's talk this one through. So I say, even though the indefinite integral, and that's going to be an integral from negative infinity to infinity, represents, and when we do that, when we just find the integral of a function, that's just going to represent a family of functions. So it's going to be, some sort of capital F of x plus a constant. That's what we have down here. And then so what bothers me is that I want to input a singular value of x in here, and I want it to make sense, or to actually yield something specific. But it can't, because if I put a value in here, you can always have this value plus c. You know what I mean? And so that's where, we look to, and I guess this is the fundamental theorem of calculus, is that you have a definite integral with a lower bound and an upper bound. And so the trick here is that I just want to put in, when I get this family of, what I want to do is be able to put in x is equal to 0, and then have this function equal 0. And then that's kind of my starting point. And then if I get that equation that will now be f of x plus c, and I solve for c, then I can put in any value of x in here, and that value is going to represent the area under the curve of the original function, starting at 0. If you start from 0, I want to find the area under the curve from that point. Now, a lot of functions like x squared, well, that value of c is going to be 0 anyway. But then there's other functions like cosine of x. Like if your integral is cosine of x, well, that starts at a value of 1. And I'm not going to dive into that, but that's where I think, that'd be the next place to take this, because those always confuse me. And it's just because an integral in general, you can't just throw a value in here and expect it to represent something significant. It might not, because this integral is a family of functions, and it can be, moved up and down along that y-axis. So if I throw in a value here, and I can get a value for this, sure, but I can always change that value by plus or minus, any number from negative infinity to infinity. Okay, hell yeah. And then so just to kind of solve this, we're going to throw in 0 here, plus c is equal to 0, and then we're going to solve for c. So c is just going to be the negative of f naught. So if I do have this integral, and I throw in a 0 in here, and it becomes 0, well, c is just 0. But if this was like 2, then my c value is going to be negative 2. And then I'm going to have, and they show this is a third equation, where if you just want that singular value to represent something, well, let's call it g of x, and that's going to be f of x minus f naught. So this is one of the equations from the family that we have chosen, and it's going to be g of x. All we have to do is just throw in a value of x into this capital F of x, and then subtract what we found over here. Subtract our c value. And then so this is going to represent the area under the curve. And so let's read this. This function g of x is mathematically equivalent to the definite integral of the function f of t from 0 to x, providing a numerical value for any given x. So there it is. So it's the integral from 0 to x. This is a definite integral. This is going to represent, this part over here represents the area under the curve of this original function f of t. And hell yeah. And that's going to now represent f of x minus f naught. The way we have it. Oh, this is just from the fundamental theorem of calculus. This is what I want to do. Like, I think it's going to be valuable going forward to do this every time in a few different ways. One, I just like the way that I kind of wrote it, is that I get this family of functions. I want a singular value of the independent variable x to be a meaningful value at that point. When I throw in x is equal to 10, I want it to represent something from the original function, and because we're dealing with the integral, it would make most sense is if I found the area from 0 to 10. And so that's all I'm doing. And it's good for me to make this just to see that that's all I'm doing. But I think it is useful, because else you just have a family of functions and it can seem a little bit meaningless. All right, hell yeah. So when so although it'd be a cool idea to evaluate, and how did I phrase this? I said, although it would be a cool idea to evaluate the value of C, that's what I'm trying to find, the value of C when the capital F of 0 plus C is 0. Or mainly C, if I rearrange, C is just the negative of that capital F of 0. Then I could find the value of, just any value, f of x minus c, or this new equation, f of x minus c, which they're going to call g of x. For any value of x that I input in here, that's going to be a singular value, and it would represent the area under the curve of f of x from 0 to x. Heck yeah. And then, all right, so final thought is, when you do get this family of functions, it can still be very useful as a definite integral, but you have to find two values for that. And that's the part that always kind of confuses me. It seems like once you get the integral, this equation, even though it's f of x plus c, it's very difficult to see that just any one value in here is kind of meaningless. You have to compare it to another value. And that's where the c's drop out, because if I evaluate this family of functions at x is equal to 10, and then evaluated this function at x is equal to 9, I'm gonna get a value plus c for the first one, and then a value plus c for the second one. And so if I take the difference between those, f of x10 plus c minus f of 9 plus c, then the c's will cancel out. And then I'll just have this function evaluated at x is equal to 10 minus this function evaluated at x is equal to 9. And that's the definition of the definite integral, or the how to set it up on this side. Our limits would be from 9 to 10 of that function, as an integral form, and then that would equal f10 minus f9. And you're going to start with original function. You're going to take a value at that function, and then you're going to multiply it by a small little width, and you're going to get a little strip of area. You're going to do that over that interval 0 to x. So if we just have this, then I'm going to get a slice here, a slice there, and then the summation. This is a summation sign where I'm going to sum all those slices. And the important thing about this summation sign is that where the width goes to 0, and then you're going to have an infinite number of those slices. And each slice is going to be an infinitely small width, and that's that dt part. So hell yeah. But again, it's just summing the slices, summing the areas. So from a visual representation, this integral is the area under the curve. It's just that when we take when we integrate this, when we take the indefinite integral, we're going to get this family of functions, f of x plus a constant. And I just want, this to be meaningful. And then so I think I should do it in two parts. I think if I'm trying to do an integral, we'll set it up like this. This would be an indefinite integral, just the integral sign, where your lower and upper bounds aren't bounded. And then you'd get this. And I'm trying to think, is if you do have, no, that'd be for another video. Yeah, some of this stuff is just like one step at a time. But then I could take that same integral and then just put a lower bound of 0 and an upper bound of x, and then just solve for that independently. And then I'm going to get I'm going to get a function. Once I do this, I'm going to have the x value here. This is going to be This is just going to be a singular value. And then I would have a equation for that represents the change in the what is this? This is just the integral evaluated at x, and then the integral evaluated at 0. And this is kind of wigging me out because they've already dropped the c value. You know what I mean? You should have this, formally this should be f of x plus c minus f naught plus c, and then those c's would drop out. But this value would represent the area under the curve from 0 to x, and this function is what I would seek every time I do an integral, just because I think that's a useful thing to have one equation that kind of represents something. Every time I plug in a value of x, I know it's going to represent the area under the curve starting from 0 up to that value of x. I could have a positive value of x, I could have a negative value of x, but it's going to be the area under the curve from there. All right, that's it. So it's just good to be able to ask a question, and if you get halfway of a decent answer, being like, yeah, that is useful. And that's what I was going for. So, booyah, thanks for joining me. Heck yeah.